Let's move to the next, which is Terrell, who will speak about iRODS configuration and node code. Terrell, the floor is yours.
Excellent. Let me see if I can make my computer work here.
All good.
Can you see that? All right.
Yep.
All right. Well, thank you for having me. I was in Copenhagen last year, and I think that was the last time I left my house. So it's good to be back with everyone. One day, maybe we'll see each other again. Let's see. So I've got a lot of slides. I'm going to go pretty quick. This year, my update is that I'm going to talk about policy composition, configuration, not code, with the iRODS work that we've done. So again, I work at the iRODS Consortium. This is a member-driven organization at the Renaissance Computing Institute at the University of North Carolina in Chapel Hill. I think we're up to 28, if you're quick and can count all these. Our members are people doing science, people trying to sell them hardware, and people who are kind of boots on the ground doing technology integration for us. We are an abstraction layer. It's a BSD licensed C++ client server application. It's been out for a couple of decades now, and we are an abstraction layer between all of your existing infrastructure and the kinds of applications that you'd like to run. We talk about policy a lot. The idea is that we provide this environment in which you can have your policy move and change over time as the needs and requirements of your collections grow and become more important, as they become just across team or across institution, and then they become relevant to science forever after, and they become part of like reference collections in the library and things like that. Here are a lot of words that are the abstract. The goal here is to point out that we've seen people do this a lot, write policy for their particular implementation. And a lot of times they end up with a monolithic, very specific thing that they've built, which is glorious for them, but not very reusable for others. And so my job is basically to see these patterns and across the deployments around the world and notice the similarities and duplication and try to build them, break them down into smaller pieces. And then the idea with this policy composition is to allow people to be able to stitch them back together into those complex use cases, but with more reusable pieces. So a definition of data management is really about having, developing and executing plans, to keep your stuff safe. And our point is that the best way to do that is to have a future-proof solution. Being open source is the way to do that. This crowd, this is not news to you guys. This is sometimes news to some of the people we talk to. In terms of what a policy is in iRODS land, it's basically a plan, a program of what to do in a particular situation, right? And the idea is that this is official because official people have said so. So they sat around a table and decided what the policy is for their particular organization, and they've tried to write it down. iRODS takes these, and the goal is to make that policy, which might just be a bunch of words, and turn that into real actionable code, right? What to do in a particular situation. So the kinds of policies that we're talking about are really about data movement, how do you verify it's good, how do you get rid of it at the right time, around metadata, extraction, application, how to make sure that your metadata is conforming to whatever standards that you need. And then of course, making sure that the bits haven't changed on disk in terms of when they're moving around, that you can verify things when you need to. So between all of these, you can do pretty complex things. So our data management model really is about providing this core set of technology, having these policies available, composing these policies into what we're calling capabilities, and then again, noticing those patterns. So when we talk to people for the first time, we hear their use case, try to figure out what it is that they're saying in their words, and try to figure out if we've already got something kind of in a cookbook or kind of off the shelf that they can use. And so as we're doing that, again, we're trying to create these building blocks, and we're doing that with existing proven software engineering principles. So we're trying to favor composition over these one and done cathedrals that people tend to build when left to their own devices. With the iRODS rules, we've got dynamic policy enforcement points, which basically are when things fire in the system. And our goal is to make them so they don't step on each other. They can be overloaded and fall through one to the other and get out of each other's way. And that allows us to stitch them back together and achieve these complex use cases. So as an example, we're going to talk about storage tiering first. The things that you have to do in order to provide a service such as storage tiering or a capability is, obviously tracking when things were touched, figuring out whether something is in violation and it's time to move. Of course, then, actually doing the movement and the verification that the bits are good, and then trimming the ones that, the source. And so our approach here is to basically pull these pieces apart and separating the when and the what, the why and the how. And once we can do that, then the policy itself is no longer tied to the policy enforcement point in the system. That becomes just the when. And the what you want to do is can be focused and separated. And then how it gets invoked is of no concern to the policy itself, and then whether it's now or later. And so at this point, you've got policies that can be separated out, they can be reused in a generic fashion, and allow you then to compose them. So we're going to go through a couple of examples. So here's the code part of the presentation. After something gets modified in the system, based on any of these reasons, we can then call this policy. So this is a synchronous access time policy. It's a JSON object that's going to be part of the rules that get fired. This is a synchronous replication example. So after any of these types of things happen on a data object, we're going to call the replication policy. And in this case, we can send it to multiple destinations. So in case we want to send a replica somewhere or a set of replicas. In this case, we want to replicate to a single target. This is the same policy, but asynchronously. So we've added this in queue capability here. And again, this is just a nested series of payloads. And we just throw it on the delay queue and it'll fire when the time has come, but it's the same policy. This is a synchronous retention policy. So again, after a replication event, we're going to call the retention policy, which means that we're going to trim from these particular sources. This would be a query-driven asynchronous retention policy. So this part at the bottom is the same, but now we've got a query that can go and find something based on the reasons in the query, and then actually in-queue things, and so they'll fire 4 at a time. So we've got parallelism now, which is a new feature that we've never had before in the system, using a generic event queue. If we want to do synchronous verification, after any of these things happen, we can verify based on either just the catalog, we can just look up things and see if it's true. We can do a stat on the file system. It's a little bit more expensive, but still a pretty good balance. Or we could do the full checksum to make sure that the data is truly what you expect it to be. Here's the same thing, but asynchronously. Again, same type of logic, but we can throw it on the in-queue rule and you can fire it within a couple seconds, just a little bit later, or next Thursday, depending on what your policy needs to be. So that's kind of showing you some of the examples of what they look like. Stitching them together allows us to do much more complex things. So this is our one-pager around storage tiering. I think I showed this last year. This is a generic view of what you might have in terms of fast, intermediate, and slow storage in your system, regardless of where they are. This is the abstract view and not the physical view. And so when you're looking at storage tiering, we've got the concept.
Time is gone.
The time is up?
Yeah. You have to go on somewhere, go to the point.
Oh my goodness. Okay, well, this is what they look like. Here we go. This is the same thing, but reverse. The point here is that data transfer node is the same idea, but flipped. And so look at all these words. The slides will be available. This is indexing. We can go to Elasticsearch with full text or purging. We think this is everything that we've seen is a subset of these 8 use cases. And the point here is that capabilities now can be easily configured recipes. And we hope in the next year or so to have a policy GUI, which is the first time we think anybody's ever had something like that, to allow people to manipulate these policies on the server side. And we think this is the future, and it requires open formats and open source. So thank you very much.
Thank you, Terrell, especially for the quick summary. Is there any question for Terrell? Please raise your hands.
I like this. Oh, sorry.
Yeah, go for it.
Go, Jon.
I really like this, and I really like what we could do with Riva and OSIS and the CS3 API on top of iRODS. But can you tell me where I can find the time to do that?
I have extra slides that explain that, but I ran out of time, so I don't have.
Just visit me later at the booth, and I'll try to find you. Yeah.
Excellent.
Thank you again for the presenter, Terrell. Let's move to the next speaker. I lost the timetable. So